So let's talk about an odd concept. And I say an odd concept because we introduce it to you and we don't really go into any depth. And the reason we don't really go into depth is because, one, there's a lot of mathematics associated with it, and two, it's just really kind of a hard concept. I can tell you from personal experience, there's a reason we're going to be focusing on bodied, centered, and cubic materials because they're very easy to understand. So as a primer, let's start out with what a crystal is. A crystal is a very organized material. It's a solid material where there is a repeating pattern in how the atoms are arranged within the material. And this basic unit that's being repeated is the unit cell. Now, the unit cell has 6 variables that are used to describe it. One for each length, so length, width, and height, and then the angle between the length, width, and the height. So those 3 angles and those 3 lengths are the 6 properties that define the unit cell. So we call these the 6 basic quadratus lattices. So you've got cubic, orthorhombic, rhombohedral, monoclinic, all these weird ones. The only one we really focus on, though, is cubic. And the reason we focus on cubic is that cubic is very easy to understand. A cubic crystal is just a cube. Just that. All sides have the same length and everything's at 90 degrees. And because of that, it's really easy to work with it because you can just tumble it around in space. There are actually 3 types, well, more than 3 types, but for this class there are 3 types of basic cubic lattices. The first is what's called the primitive lattice. And this is designated with the letter P. Now a primitive lattice has 1 atom at each corner. And there are a few metals that will pack in what's called a primitive lattice structure, meaning that if we were to reduce it down to the simplest structure, we would just have 8 atoms, each touching each other. The problem is the primitive isn't the most efficient way of packing a crystal. And so there's 2 others that commonly occur. The first is the bodied centered cubic, so B, C, C. Bodied centered cubic. And the way a BCC crystal works is that you've got these 8 atoms on the edges, and inside, actually let's do this with a different color. Inside, we've got an atom in the very center. So a bodied centered cubic is one that has an atom in the body of the crystal and it's centered. This is a more efficient way of packing the crystal, and there are a lot of metals that will do this. We also have the option, instead of putting one in the center, is putting an atom in the face of each side. And so these are face centered cubic, or FCC. Now for a face-centered cubic crystal, we've got 6 faces to each side of the cube, and in the center of each face, we're going to have an atom. 2, 3, 4, 5, 6. So we're going to add 6 more atoms in here. Now it's a bit hard to see on this diagram, and hopefully I'm able to superimpose a picture on top of this in the video. If I did, good for me. But these are really the 3 cubic lattices we like to focus on. In this class, we're going to focus specifically on the bodied centered cubic and the face centered cubic. So the next couple of videos we're going to go through to figure out the theoretical density of a BCC and FCC crystal based on the fact that this is just a simple cubic crystal.